We have inverses for addition and for multiplication. Now notice the nature of the question that the inverse asks. It says, hey, I'll give you a real number A. Can you tell me what real number I can add to A and get the identity element for addition, namely 0, as a result? What could I add to A and end up with 0?
The opposite.
Which is in this case is going to be?
Negative.
Negative A. And you have answered both questions that I have with your single statement. Negative A is the value I would add to A to get 0. And what do we call that? The opposite. Very good. These inverses are called opposites. And that's why this is called the property of opposites. It says for every number, there is a number called its opposite that I can add to it and get 0. Is that true? For every number?
Yes.
So for negative 7, what can I add to that?
7.
For pi over 13, what can I add to that? What are you doing to get the opposites? Changing the signs, right? You're changing the sign. So you change the sign of the number, and you've got its opposite. What number do you think might be a problem? Doesn't have a sign, does it? What's the number? 0. 0 is where you always go to find problematic or maybe exceptions to rules. Does 0 have a number I can add to it to get 0? 0. No, yeah. So it does. So 0, ladies and gentlemen, has an opposite. It just happens to be itself. So 0 plus what gives me 0? Itself. So 0 still has an opposite. Just happens to be a little strange. It's the same number. Hey, that would lend itself to some true-false questions. Like every real number has an opposite. True. True. I found that one. Every real number has an opposite. Let's look at the inverses for multiplication. This is a little bit sticky. It says for every real number A, there's a number I can multiply it by and end up with the identity element for multiplication, which of course is 1. What can I multiply A by and end up with 1? 1 over A. Very good. Now remember, A times 1 would give me A. That wouldn't quite cut it. But A times 1 over A would, in fact, give me 1. These are called multiplicative or multiplicative inverses. And it says you give me a number. There's a number you can multiply it by to get 1. What would that be?
1 over 7.
1 over 7. What would that be?
3 over 10.
Ah, now you're getting a understanding. What are those two numbers called in context?
Reciprocals.
Reciprocals. So this is called the property of reciprocals. These inverses are called reciprocals. I want to fill in the blank?
Negative.
We have 7 and 4.
We think it has to be negative. Sure. Why does it have to be negative?
Like negative times negative.
That's right. I have to end up with a positive 1, right? So I can say something like this. Reciprocals have the same sign. True or false?
False.
Reciprocals have the same sign. True or false?
True.
Give me some reciprocals that have different signs.
No, it's true.
It's true.
Oh, it's true now that I'm asking for an example, huh? Yeah, that was sneaky. That's right. You think about it, ladies and gentlemen. 7, 1/7 are both positive. Negative 4/7, negative 7/4. They're both negative. So reciprocals have the same sign? Yeah. They either both have to be positive or they both have to be negative in order to give a positive one. All right, we've asked this question before. I think you probably know the answer. Any exceptions to this question? Any exceptions to this reciprocal concept?
Zero.
Oh, there is an exception? So you're saying 0 doesn't have a reciprocal? Let's see. So you're saying that 0 doesn't have a number you can multiply it by to get 1? Is that what you're saying?
Yeah.
What can you multiply 0 by to get 1?
Nothing.
Nothing? You mean 0? When you say nothing, or do you mean? Oh, I see.
Nothing.
So there's nothing I can multiply 0 by to get 1, because anytime I multiply 0 by something, I'm going to get 0. So you're right, there is an exception, and it is 0. 0 is the number that does not have a reciprocal. No exceptions to the opposite concept. Every number has an opposite. Any exceptions to the reciprocal concept? Yeah, 0. So that lends itself to some true-false questions, like every number has a reciprocal. True or false?
False.
False, because just one doesn't, right? So when I say every number has a reciprocal, you realize I'm talking about universally, and there is not a universal application. There's, in fact, one exception. All right, true or false? Negative 2/3 and 2/3 are good examples of reciprocals. True or false?
False.